integral of x e to the x, and you've never seen integration by parts before. What do you think the most common guess is for the integral of x e to the x that people make when they first do this one? What do you think the first most common guess is? X e to the x. So like e to the x is the derivative itself. X is derivative. How do you test that potential answer? So you think people are like, okay, it's x e to the x. Well then, I as a teacher, what would I do if I wanted to show you that that's probably not correct? What would I do? Yeah, do d dx of x e to the x. And then what do you need to use when you do this? Well, product rule is the dictator here. The derivative of the first times the second plus the first times the derivative of the second. Oh, wow, there's an extra thing there. What did it kick out for us? E to the x. Exactly. Okay, so if we're going to do this by investigation, therefore we kind of kicked out this extra piece. What do we think the integral should be if when we did the derivative we had this extra thing? So if we wanted to make another guess, what do we think it should be? This didn't work. We have this extra piece. We want to take it away, right? It's minus. So make it x e to the x minus e to the x. That might be our guess if we were doing this by guess and check without having a system. So let's actually do that out. What happens? We do d dx of x e to the x minus e to the x. What does that come out to be? Well, that's e to the x plus x e to the x. That's the derivative of the first part, right? And then what's the derivative of minus e to the x? Minus e to the x. Oh, does it actually work? Yeah, it does actually work, and you end up with what you want. So did we actually find by guess and check and investigation the actual answer? Sure, it does work. Why isn't guess and check always going to be super helpful for us? Yeah, it takes time. There's no finite ending. And, what did you say? Yeah, things that are much more complicated. Now, is by parts going to solve all of our problems? No, it's not. But does it give us another way to attack things that we recognize with certain characteristics? Yeah, absolutely it does. Absolutely. So, yeah, here's another one I would throw at you if we were just starting out. You try it out and be like, oh, cosine, maybe it's sine. And then does it kind of work? And then you kind of subtract something, maybe it might work, and all these stuff just falls to the ground over there. What is this phrase right here? What was applied to the functions u and v? The product rule was applied to the functions u and v. If you want to undo a derivative, what do you do to both sides? Yeah, if you take the integral of both sides, we're going to end up with, if we integrate, yay, we like to integrate. What do we end up with? uv equals the integral of this thing, right? u prime v plus uv prime. Do I have any idea why they pick letters that sound and look alike? No. I think 800 years ago, someone was like, let's mess with people in the future. When you're integrating the sum of two things, what can you do to both of those things? They take the integral separately, exactly. So you have u, it's going to be uv equals the integral of u prime v plus the integral of u v prime. And then usually, how do you see this? What gets subtracted from both sides? Does it really matter what we subtract from both sides? You kind of get the same thing each time. Let's do this. uv minus the integral of u prime v is equal to what? uv prime. Exactly. You generally see something that looks a little bit like this right here, where here's where you're starting. You're starting with the integral of something, and you're turning it into the product of two functions minus the integral of two other things. Now, can someone cleanly explain why this is actually pretty helpful for us in certain situations? I mean, it seems like it makes it worse, right? You take something and you have something else. Why can this effectively help us? Yeah. Yep. It's much easier, exactly. So this thing is just sitting there. There's nothing else needed. But sometimes it's a small change, right? It's a small change. Sometimes this is not easily integrable, but this one is easily integrable. Exactly. So, yay, wonderful, woohoo, uv prime, nice. Everything in parts comes down to this blue box, or really this one line at the top, which is how do you choose u and v prime? How do you choose them? And he gives you three things. Whenever you let v prime be, you need to be able to find v. So if you choose v prime to be something, you better be able to easily integrate it. If you get stuck at that point, choose something else. It helps if u prime is simpler than u. Well, it helps. Then again, is the word simpler subjective? Like sometimes you don't know if it's simpler or not. Sometimes you blow it up to make it doable. It helps if v is simpler by taking v prime. Yeah. So it helps if you have normal kind of normal-ish behaviors, but they aren't absolute. So here's a nice one. Is this an indefinite or a definite integral? It's a definite integral. So our first step is me telling you we're going to use integration by parts. Are you always going to be told you're going to be using integration by parts? No, you're going to sometimes need to recognize it. In this case, you kind of only have a few things to use here. You have like stuff in your head and integration by parts, right? There really are very few integration methods that you need to know for the BC Calculus exam. So on this one, like any integration by parts problem, you have to start off by picking u and v prime. And it's totally, at the beginning, don't obsess over trying to get the right thing the first. Just pick and see if it works. Anybody want to try to guess what u is going to be? Ali. Yeah, ln x. So what does that make u prime? And if u is ln x, what's left for me to pick for v prime? 1 what? Dx. Just call it dx, okay? Call it d. It's 1 dx. So what is v going to be if that's the case? X. You integrate to get to there, and you differentiate to get to there. That was a really terrible arrow right there. That's better. Are you with me so far? So what did this look like? And one of the easiest ways to get this wrong is to someone have the charger quick? I don't want to get stuck again. Oh, I need one. Anybody have it? Can he make it in time? Look at that. Okay. So one of the quick lead-off. What's always the lead-off? UV. So what's our UV going to be? ln x times x, right? And what are we subtracting? U prime, which is times v, which is what? Oh, look at this. And we're integrating, right? What's 1 over x times x? So what do you end up with? X plus c. Nice. Now that's the indefinite integral. If we wanted to evaluate it, could we now evaluate it from 2 to 3? It would go away. I'm just putting it there to remind you that it's there. But do you see how cool that is? So sometimes you get really nice summative work like that. Yeah, it cleans itself up. It cleans itself up. Okay, let's ramp up the difficulty level. Go ahead. Let's make it a little bit more challenging. What about this one right here? What do we first have to do if I tell you it's by parts? First thing you should do is do what? U, v prime. So what do we think u is going to be? Let's do ln x. So what's u prime going to be? 1 over x, yeah, dx. Nice. What about v prime? That means it's going to be what? X to the 6th dx? So what is v going to be?
1/7
I have to integrate, right? 1/7 x to the 7th. So we have u times v, so that's going to be x, not dx, sorry. It's going to be 1/7, sorry, thank you. 1/7 x to the 7th times minus the integral of u prime v, right? What was u prime v? 1 over x dx times 1/7 x to the 7th. Does that actually help us out? Well, what's 1 over x times 1 over 7th x? Yeah, it's going to be 1 over 7th x to the dx. And now are you home free? Does everybody know what that means? Are you 99% done at this point?
Yeah.
When you see this integral, do you feel happy, sad, or nothing? Happy. You feel happy. There we go. I feel nothing. That's actually a really dangerous disorder. You should not, be careful around cooking devices, At this point, what do you feel? You cry a little bit, so you kind of like this? Is it that? Is that what you feel? Why do they feel that, Brenna? Why do they feel that? Yeah, it seems like we just made it more complicated. Or maybe not more complicated, but is this much different than this? Not really. There's some constant differences, right? Do you agree with that? There's some constant differences? Yeah. So could we clean it up a little bit? Let's see. Let's clean it up a little bit. What do we have here? 1/3 x cubed sine of 4x minus what? Thirds cosine of what? Cube dx. And at this point, you're still kind of sad because it seems like you haven't gone anywhere, right? Well, I have an inkling about something. Who knows? Let's just, you might be cruising along and you're like, hey, okay, if I just gave you this one to begin with, you might try using what method on that one right there? You might try integration by parts, right? If we were to do integration by parts on this one, what's our u going to be? What's our v prime going to be? Let's do the same thing. What did we say u was? What's u going to be in this case? Cosine of 4x. So what's u prime going to be? Negative 4 sine of what? Dx. So that's going to make v prime what? Dx. So what's u going to be? Fourth. Okay, so if we plot this together, what do we get if we put this together? What's u times v? It's going to be what? 1/4. Yeah, negative 1/4 x to the fourth, like this. Correct? Times what? Cosine of 4x minus the integral of what? Yeah, well, hold on. Minus the integral of what? Don't do the simplification quite yet. Minus what? Negative 4 sine of times. Is it 1/4 x to the fourth? Times 1/4 x to the fourth. Is that correct? U prime. Oh, this is v. Sorry, I just wrote it wrong. Thank you. U prime v. Are we okay so far? So let's simplify this just a little bit. We have this plus what? Dx, right? So we found out that this right here is that, correct? Let's write down, hold on. One of my negatives is incorrect? You're going to be staring down something like this in the future and think to yourself, am I missing something? Am I missing something? I don't know. Is something there? I don't know.